In this episode of Quick Tip Tuesday, we'll take a look at how we can create a simple laser beam using just a few nodes and a few lines of code that's going to intersect, expand, and change length depending on how far or how close our collisions are. To begin, we're going to start with a blank scene and we'll add a node in here that's going to be a raycast 3D. Underneath our raycast, we're going to add a mesh instance 3D. For the mesh, we'll give it a laser-like shape, so we'll start off with a cylinder mesh. And we'll just come in and we'll modify these values. And I found that 0.1 by 0.1 by 0.1 works out good for us. And if we zoom in, we'll see that it just gives us a flat-ish cylinder that we're going to use as the base of our laser. We're also going to have to add a material to this. So we can just use a new standard material, and we can start to play with the color to get it to look like a laser of how we want. With that looking good, we can move on to the emission, and we want to enable this so we can give it a glow, and we'll give it a similar color. This time we'll go with a nice dark red, and we'll turn up that energy multiplier. Minimizing our material, the last thing we want to do here is flip faces, and that's just going to make it so it's easier to see this mesh in our 3D world. And lastly, we want to go to our raycast and just update the target positions. That way, this is going to collide when we get it in the scene. So I like to set it to something like -50, -100. You'll have to play around with this if you want it to collide over a large distance. With all this done, I can rename my nodes and then save my scene in my scene directory. Moving on from this, we'll want to add a script to this scene so that way we can control the size of our mesh to make it look like a laser beam in our scene. The changes we have to make to this script are pretty simple, and I'll just use an onReady variable at the very top to call our beam mesh later in our script. We can skip past the ready function and focus on the process, and we'll start off by just calling out a variable here for the contact point. And we're going to later set this to be where the actual beam is going to intersect with other bodies. So we'll call that contact point. And then to make sure that our raycast is being updated every single frame, we can force a raycast update. And then this is where the actual brains of the operation come into play. And we'll say that if this thing is colliding, then we are going to set the contact point of it, and we'll say to local. So setting this to local coordinates, and we are going to get the collision point. So we're going to figure out if this thing is colliding, then we're going to get the point at which it collides, and we will set that to the local coordinate system. With that set, we can call and find our beam scene. So that'll grab that beam mesh thanks to our variable. And then I can grab the mesh from that, and finally the height. And we will set that to our contact point.y. So we're going to grab the y value of that collision point, and we're going to set our beam mesh height to it. Now, because these scale from the middle, we'll have to similarly go and grab that beam dot position in the y direction, and we can set that to our contact point dot y divided by 2. And with that set, our script is basically done, and we can utilize our laser beam scene in our world. I'm going to pop back over to just that beginning playground that we've been working with, and I can instantiate a laser beam. Now, this will go in the middle. So we will have to reposition this as we go through, and we'll have to rotate this around as well so our raycast is going in the right direction. So I'm just going to position this somewhere up against this wall here, and maybe just tuck it in a little bit closer. And we can see that the raycast is going to go, it'll intersect with the block on the other side. So finally, when I hit play on my scene, we go into our game, we're going to have a laser beam here that stretches the extent of this. Now, because we're using collisions to detect this, if I move my body in front of it, it's going to stop the collision. And we can play with this. We can move our collision body to a different collision layer to avoid this. But now we have a working laser beam inside of Godot.